Hi, welcome to the Quadratic Formula with Adnan and
Hi.
Shane.
Alright, so today we're going to talk about the quadratic formula, but there are different types of writing the quadratic formula, and one type is the vertex form.
The vertex form looks a little something like this. Y minus k is equal to a times x minus h squared. But you could switch it to y is equal to a times x minus h squared plus k. This is what we're going to be using for today.
So here we're trying to find the vertex using the quadratic formula, and for that you look specifically at the h and k part of the formula. So here's an example problem here, and you look at x minus 3, so that would give you 3 for the value of h, and negative 4 for the value of k. So that would be, here's what it looked like in coordinate form, and then you'd look at it in graph form. So when we want to graph that, you would move 3 units to the right and 4 units down. So this would be your vertex plane approximately. Then we know that it's going to be going up because the a value in this is positive. So, and since it's 4, we know that it's going to be a little skinnier because that tells us the widthness of the graph. So yeah, that's what it looked like.
Hi, so we have an example here on how to use the vertex form in the quadratic equation. So in this case, we're going to be throwing a ball and seeing how high it gets and at what time it'll get its highest height. So in real life, the gravity is negative 5 meters per second squared. We're throwing this ball at 20 meters per second, and our starting height is at 0 meters. So looking at our original equation for the vertex form, y is equal to a x minus h squared plus k. We need to convert what we have here into this form. So we're going to write it out as y is equal to negative 5x squared, which is gravity, plus 20x, which is the speed, and plus 0, which is the starting height. So through lots of math and other stuff like that, which is cool, we have our equation down here, which is y is equal to negative 5 x minus 2 squared plus 4, which equals this equation up here. Pause it. So we can apply this equation into a parabola to see how high it'll get and at what time the ball will be at that height. So right here, Adnan has put the vertex, which is at a height of 4 in 2 seconds. So at 2 seconds, the ball will go as high as it possibly can. So right now, Adnan's going to draw the parabola of what it will look like. As you can see, the parabola goes down because it's a negative 5, which makes the opening of the parabola point down. So in this equation, the longer the time goes, up until 2 seconds, the higher it goes. But once it reaches 2 seconds at a height of 4, it's going to decrease in height. So at 4 seconds, it'll hit the ground again. This is a way we can tell how high the ball will get if we throw it and how long it'll take.